is factor and find all the zeros. You can't factor by grouping with this one, okay? So we had to run synthetic. So by doing that, you have to figure out the list, okay? Typically we start with 1, -1, but those two didn't work. So when in doubt, as you go through the list, the next in line, because it's 48, would be 2 and -2. After that would be 3 and -3. Or, in this particular instance, since you have your calculators, you could graph it, okay? And use the zeros given to you. We actually see them already, okay? And again, this was a degree of 3, right? So we should have 3 zeros. Looking at it, we could start, say if it was a degree of 5, you could start with whatever's given to you, okay? So if you started with -3 and ran synthetic, or as you go through the list, and it took a few tries, okay? -3 does work as we just saw. So that's -3, and then x plus 3, we have a degree of 3. What are the other zeros? What is the other zero? Yep. 4. So when we have x squared minus 8x plus 16, x minus 4 squared. So, okay, this would be your equation in factored form. So if you had to graph this, if you had to graph it, at -3, what's happening? We're crossing. At 4, what's happening? Touching. Okay? So, we use to find the zeros to also help us with graphing. Okay? Then you get to number 2, where you're factoring and solving. Okay? Doing what we've been doing the whole time. So, how would I factor this for A? How would I factor that? Yeah.
First, I put in the calculator the equation to get zeros, and then I plugged in the synthetic division, and then got a shorter equation that I could factor easily.
Okay. Okay. Anybody else? Yeah. Okay. So, at first, okay, if you had this, again, the exponents are just doubled, which is absolutely correct. You could do it the calculator way as well. But this could be a non-calc situation, okay? Because what multiplies to 36, -36, and adds to 5? The only thing different is your exponents are doubled, okay? This is in quadratic form. So from here, we have x squared plus 9 and x squared minus 4. But like Kip said, we could keep going with x squared minus 4. Now, we have to solve, okay, because it's set equal to 0, and we're finding the zeros. So x squared plus 9 would be what? What would be my solutions? Jax?
Would it be plus or minus 3i?
Yep, plus or minus 3i. Excellent. Then we have 2 and -2, which makes up our 4 solutions. 2 are real and 2 are imaginary. Okay? Now B, you can't factor by grouping, so we have to use synthetic division. Okay? By using testing zeros. Did anyone find the zeros for this? Yeah, Campbell. 1 was the first one that worked. Okay, so right now we know our zeros are 1, okay? Then we're left with x squared plus 8x plus 16. Can I factor that? How? Yeah, Campbell. Good. So we have x squared, x plus 4 squared. So my other zero is -4, which has a multiplicity of what? 2, right? Okay. 1 has a multiplicity of 1, but since this is x plus 4 squared, it has a multiplicity of 2. Okay? All right. Now, number 3. How many solutions should we have? Ryder? 5. We should have 5. What were some that you found? Jaden? -1 and 2. Okay. Anything else with -1? Jaden? It did have a multiplicity of 2. Okay. So at -1, okay, I'm going to try -1 again. Oh, there's an extra 1 in there. Okay, so how would I write that as a factor? How would I write -1 as a factor then, if it has a multiplicity of 2? Eliza? Yep. Good. And then if you did this again with 2, with your new numbers, okay, 2 also did work.
How would you know if it has a multiplicity?
If it happens twice,
Oh,
okay, or more than once. Okay, then you're left with here, so your other factors, since can x squared plus 4x, x squared minus 4x plus 7 be factored? Yeah. So, okay, if that can't be factored, what do we have to use to find the other zeros? Eliza? Yep, quadratic formula. So we have cannot be factored and they're asking for zeros, you have to use the quadratic formula if it's finding all zeros. How can I simplify? So from here, once you're in the quadratic formula, you have to simplify. So we have 4 plus or minus 2i root 3 over 2. Now from here, 4, 2, and 2 can all be reduced. Those are your other 2 zeros. Okay, so we have 2 plus or minus I root 3. Okay, that makes a total of 5 because -1 has a multiplicity of 2. Okay, -1 has a multiplicity of 2. Then we have 3, 4, and 5 to make a total of 5. Okay, and again, if you've noticed in most of our examples, complex numbers do come in pairs. Okay, so they count as 2. Questions? Yep, Campbell. when I did the 2 here with the, and I erased it, so I apologize for that. Nope, that wasn't it. Hold on. My numbers are all, that's 6. Sorry, I erased it for you. Was that negative? Hold on. I'm confusing myself by what I have written. -6. Get 4, there we go. And then you're left with x squared minus 4x plus 7. Okay, sorry about that. All right. So if it's asking for all zeros, okay, it's both real and complex. Okay. So the next one takes a little bit of work. Okay. And we're going to do this. Some of you did not get to this, but it was supposed to be 1 through 4. Okay. So we are going to go through this together. With your calculator, we're going to do some work with that because I know some questions might have been for the homework, okay, in terms of adjusting the window and all that stuff. All right. So looking at this example, what degree is it? Yep. Careful. Close. No. You're closer with the 5th. Yeah, Noel. The 6th degree, because here's the other x right here. So you have 3 here. 2 is 5, 1 more. So it's the 6th degree. Okay. Factored form. It's already in factored form. Okay. Before we get to the y-intercept, what are the x-intercepts? Charlie? Okay. Keep going.
1.
Yep. Good. So we have 0 because of the 2x, 1, 0, and -3, -1, 0. Okay. 1 has a multiplicity of 3. -1 has a multiplicity of 2. So if I already have an x-intercept of 0, 0, the y-intercept is also 0, 0. And you could do that by substituting 0 in for x. Okay? Now, it's an even degree, positive leading coefficient. So what is my end behavior? The same. In what direction? Up. Good. Okay. So, looking at our x-intercepts, at 0, what is happening? Touch across. Yep. Cross, you are right. X minus 1 cubed. Excuse me. Cross. It's going to look a little different, though. I will show you that. And at -1, what's happening? Okay. So let's take out our calculators. Go into y equals. Okay. And we're going to enter in 2x parentheses x minus 1. Use the little caret for the cubed, but make sure you press the right arrow. Then x plus 1 squared. Excuse me. Okay. Everyone okay? Press graph. All right. Yours might look very, very close together, okay? Very hard to see. So if it is, if it's hard to see, in this particular case, you could use zoom, number 2, because all we're doing is literally, it's very small window here, so we're just zooming in a little bit. Just hit enter. Did you press zoom in? At this, okay, we see the -1 bouncing, right? Does that make sense? Yep. At 0, we are crossing. But if you notice, at 1, it kind of flattens out, but it's still increasing, okay? That is called your inflection point. We learned about it back in functions, okay? So, yes, it's still crossing, but it's called an inflection point, okay? It is still crossing, and it's not considered a constant, okay? It's not flattening out. It's still increasing, just kind of pares down a little bit, okay? Yes?
I think for some reason the graph that I have is not.
Make sure you have this entered.
Yeah, I do. I think it's
Okay, what do we have to look for first? Yeah, maximum, okay? So I'm going to show you second trace. We'll look for the maximum first, number 4. And I'm just going to move my cursor as another way to show you instead of the x-intercepts. I moved it too far. Okay, I'm going to hit enter when it says left bound. Move my cursor to the right of the curve, hit enter. Then it says guess. Okay, so my maximum, jot it down because I will forget. -0.5 and 0.4. So that's our maximum. We could already tell what one of the minimums is. Yes, Kate.
So I'm just confused that move to the cursor, I kind of skip sorry.
It's okay. All right. One of the minimums we could tell is what? What is one of the minimums? Look at it. What is that? -1, 0. Remember, we're finding the actual point because we need it for increasing and decreasing. Okay, so just to confirm, second trace, number 3, the minimum. I'm going to move my cursor to the left. Eventually when it gets there. I'm going to hit enter. Move it to the right. Hit enter. Then enter again. Okay. Some of you might have saw this on when you were doing your calculations for homework. This e to the negative whatever. That's scientific notation. Okay, it's 2.971 times 10 to the -11th, which means you're moving the decimal how many places to the left? 11, which means it's 0. Okay, so anytime you see e to the negative whatever, it's close to 0, which we could see as well on the graph. Okay, so we have a minimum of -1, 0. The other one we have to check is this one here. Okay, so let's go through second trace. Number 3, and this time I'll use the x-intercepts. 0, hopefully it works. And 1. Okay, and my other minimum, and you could do this with left bound, right bound as well. Okay, the other minimum is 0.33 and -0.35. Okay, So those are pieces of information you need in order to find increasing and decreasing. Okay? So some cases, which I knew last class, some of you were having trouble in terms of looking for the increase, decrease. Okay? If you have your calculators, what I would do, one of the easiest ways, is look at the graph and go from there. Okay? Go in order. Decrease. Negative infinity to -1. Right? Then we have increase from -1 to this maximum value. Then we have decrease from this maximum value to this minimum value, the x values. Then from this point, this minimum, which was 0.33, to infinity. The whole thing is increasing. Okay? So from 0.33 to infinity, it is still, that inflection point still means it's increasing. You're not flattening out, it's increasing. Okay? Right? So use the graph as you're going piece at a time, especially when you have zeros close together and jumbled together. Because on the graph, on your own graph, might be hard to see. Yes?
What's an use the x-axis, right?
The x values, yes. Okay. So I'll just write my increasing. Okay. So now you have to use the x-intercepts for positive and negative. Okay. So if I go back to this graph, we are positive. Remember, if it touches 0, you have to break it up. So negative infinity to -1, u, -1 to 0. Okay, that's where the graph is positive. Negative infinity, -1, u, -1 to 0, then u again, 1 to infinity. Okay, remember, if it touches that 0 on the x-axis, you have to break it up. Okay, what is my domain? Good. Negative infinity to infinity. What would be my range? Yep. Perfect. Excellent. Okay. Any questions? The hardest part is probably the calculator. That's it. Okay. Hardest part is probably the calculator. Did you have any questions from the homework? Yep. It's already in factored form. Yep. The homework. Kate? The x-intercepts? Using the x-intercepts or moving the cursor left or right? Yep, both of them work.
I think I was just having trouble. So, if you have two x-intercepts, but on the graph it doesn't look like the maximum is still use the x-intercepts.
You can, however, just the last one that we did, like for the warm up, kind of the longer warm up. On my calculator, I didn't zoom in at all, but I used the x-intercepts and it didn't calculate. And again, I was rushing through it, so it should work every single time. But if something doesn't look right, like say if you did it and it's saying 0 is a minimum, then you might have to adjust the window by zooming in so the calculator can literally see it. Okay, but you'll know if it doesn't make sense by where the ending cursor is. Okay, but left bound, enter, right bound, enter. Moving the cursor works all the time. X-intercepts are just a little bit faster. Okay. Any other questions? Okay, clear off your desk.